Hey y'all, it's Miss A. Today we're going to be spending one more day on looking at just basic ratios, but today we're also going to be determining if they are equivalent. Okay, so hopefully y'all have been finding ratios pretty easily. We're just finding a comparison between two different things and making a fraction and putting them in with a colon in between them. So let's get started and look at these. So you can notice here we have A through D, and they all have hearts. Some of them shaded, some of them are not. And then down here below, we have some questions that we are going to answer off of these. Remember that I do have a copy of this in Canvas, so if you're at home and you have a printer, you're more than welcome to print it, so you have it and you can write on it. All right, so the first one says, which set above shows a ratio of shaded hearts to, remember that's our keyword that tells us that it's a ratio, other than the word ratio, shaded hearts to white hearts. Okay, so our ratio needs to be shaded to white. And I'm going to write these as fractions. That's just how I like to do it. But shaded hearts need to come first, white hearts need to come second, and it gives me the ratio of 1 to 5. 1 to 5. So I know that the number 1 goes with the first piece, shaded. And I know that 5 goes with the second piece, which is white. Next time I'll write it as a regular ratio, since that's how they gave it to me here. So I need to find the image above that has 1 shaded heart and 5 white hearts. So let's do the 1 shaded first. That has 1 shaded. This one does not have 1 shaded. This one has 1, and that one does not have 1. So we're down between A and C. The next part, it has to have 5 white hearts. So 1, 2, 3, 4. That's not right. 1, 2, 3, 4, and 5. So C is the correct ratio. And you're going to have questions like this on your assignment today. There's going to be several of them. All right, the next one says, which set above shows a ratio of shaded hearts to total hearts? And the ratio again is 1 to 5. So this time we're going to have shaded to total. Shaded to total. So I have that written. And then 1 to 5. So 1 goes here and 5 goes here. So now I'm looking for the image, and we've already eliminated 1. We're looking for one that has 1 shaded and 5 total. 1 shaded. We did that earlier. This one had 1 and this one has 1. So if I did this correctly, then A should be my answer. 5 total hearts. So when we say total, we're going to include everything. 1, 2, 3, 4, and 5. So that's correct. So A is represented here. All right, which set above shows a ratio of white hearts to total hearts? So this time we have white first, 2 is our colon, and then total. White to total. And again, that ratio is 1 to 5. So 1 white and 5 total. 1 white. So here I have 1 white. Here I have 1 white. But I need to have 5 in total. This one has 1, 2, 3, 4, and 5. This one has 1, 2, 3, 4, 5, and 6. So the one that has 5 total is B. And if I did this correctly, the last one should be D, but we're going to check it just to make sure. Which set above shows a ratio of white hearts to shaded hearts? Again, 1 to 5. So white needs to go first, colon, shaded needs to go second. And since it's written that way, 1 to 5 goes, 1 goes with white, and 5 goes with shaded. 1 goes with white, and 5 goes with shaded. So 1 white, that's correct. 5 shaded, 1, 2, 3, 4, and 5. So we are correct. So D is represented here. So this one was tricky because every ratio was the same, 1 to 5. We had to make sure we knew what the ratio was referring to in order to get the correct answer. Because a lot of these, every single one of them has a ratio of 1 to 5. That's 1 and then 5 total, 1 and 5 total. This has 1 shaded, 5 white, 5 or 1 white and then 5 shaded. So all of them had a ratio of 1 to 5, but we had to focus on how it was asked to know which one was the correct answer. Very important. Okay, make sure you write out the ratio first, the way it's given. First goes in the beginning, second goes at the end, and then match up with the numbers. Okay, if y'all struggling with that at all, please contact me on Zoom so I can help you. And then the last thing we're going to talk about is what's a little bit new in this equivalent ratios. There are several ways to determine if two ratios are equivalent. Remember, ratios are just basically fractions, the comparison of two things, and two fractions can be equal to each other. The ways we're gonna look at two ways today to determine if they're equivalent, and that is by finding the cross products, which is cross multiplying. And then we can also multiply or divide straight across if we can find that relationship, which we did several units ago when we were solving proportions and stuff. All right, so the first thing we're going to look at is finding cross products. So it says determine if the given ratios are equivalent. So my first ratio is 3 to 4, second one is 12 to 16. So the first thing I'm going to do in order to determine if they're equivalent, I'm going to write them as fractions, okay? Because side to side this is kind of harder to see. So 3 to 4 is 3 over 4, and then 12 to 16 is 12 over 16. So to determine if these are equivalent, we are going to do the cross products method, which is cross multiplying. So we're going to multiply these two together, 16 times 3, it gets me 18, 3 plus 1 is 4. I'm going to put that answer up here at the top, 48. Now I'm going to multiply these two numbers together, 12 times 4, okay, that you should know that one, 12 times 4 is 48. So because these two numbers are the same, these ratios are equivalent. So are they equivalent? Yes. If the cross products are equal, then the ratios are equal. All right, let's do one more. 2 to 3. And if you want to, go ahead and just pause this video, do this on your own, and then see if you get it correct. So we have 2 to 3, 5 to 6. So we're going to cross multiply 2 times 2 times 6 is 12, if I can think. And then 3 times 5 is 15. So my cross products are not equal, so these fractions are not equivalent. So no, they are not equivalent. Pretty easy, cross multiplying. You just make sure you multiply the two that are crisscross, and if the cross products are equal, then it's a yes. If they're not equal, then it's a no. All right, and then the last way we're going to determine it is by multiplying or dividing straight across. This one might be harder for you if you are not very confident in your multiplication facts. This might not be the method to go, but hopefully the numbers are pretty small and you can see them. And again, you can use your multiplication chart to help you if you need to. So again, we're going to start off by writing these two ratios as fractions. 6 to 7 is 6 over 7. 12 to 14 is 12 over 14. And we're not going to cross multiply, even though you could if that's the method you choose to do. But another way we could do it is try to find a relationship going across. And this relationship has to be through multiplication or division. The fractions have no way of being equal if you just add across or subtract. It has to be multiplication or division only. So I'm looking at 6 to 12. I know the number got bigger, so I know I'm multiplying. Now I have to figure out what I'm multiplying by. 6 times 2 will get me 12. Okay, 6 times 2 is 12. In order for them to be equivalent, I have to do the same exact thing here at the bottom. 7 times 2 is equal to 14. So because I'm multiplied by the same exact number, I know that these two are equivalent. Because we multiplied by the same factor for the numerator and the denominators. All right, and then the last one is 20 over 33, and then 4 over 11. All right, now again, we're finding that relationship going across, but notice now that my number got smaller. It went from 20 down to 4, so I'm not multiplying because multiplying makes it get bigger. We are actually dividing here, and I know that 20 divided by 5 is 4, or vice versa, 4 times 5 is 20. You could look at it the other way. 20 divided by 5 is 4, and then down here, 33, and I want to get to 11. So 33 divided by 3, 33 divided by 3 is 11. So because these two numbers are not the same, these two ratios are not equivalent. You would have to divide by the same number for the numerator and denominator. All right, so this is the two ways you can determine if ratios are equivalent. You can choose the method that you like the most. If you're confident in your multiplication division facts, or you know how to use that your chart to help you, then this might be the method to go. If not, cross multiplying is really easy too. If y'all have any questions, please don't hesitate to ask. Y'all have a great day, and I will talk to y'all soon. Bye, guys.